right, so before we get into factoring difference of squares, I just want to look at some vocabulary a little bit. When you've got a trinomial, that's what this is. It's a trinomial because it has three terms. One, two, three. Each one of these is called a term. Terms in a polynomial are separated by a positive or negative sign. They're added or subtracted, so those are all three terms. This x squared term is called the quadratic term because it is a quadratic. It's a second degree. That's what a second degree term is called. The middle term is called the linear term. It's the plain x, the x with the exponent of 1. And then the last term with no variable is called the constant because it doesn't have a variable. It doesn't vary, so therefore it's constant. The little number up at the top is called an exponent, and then the numbers in front of each of the variables are called coefficients. And altogether, this thing is a quadratic trinomial. It's quadratic because the highest degree is 2, and it's trinomial because it has 3 terms. Now, sometimes when you have quadratics, you don't have a middle term. Sometimes you have a quadratic with no linear term. So you have a second degree term, and then you have a constant, and there's no middle term. So the first thing you want to do is check to see if there's a greatest common factor. And if we're looking at these two, there's not. So there's nothing that we can factor out. Then, if it is a binomial, and if it's a difference of two perfect squares, then this is one of the easiest quadratics to factor. We can factor this using a method called difference of squares. So you might want to review your perfect squares. What does it mean to be a perfect square? All of these numbers are perfect squares. It basically means if I give you 9 things, you can make a perfect square out of those 9 items by making a 3 by 3 with them. So you can make a perfect square out of a 3 by 3. If I were to give you 16 items, you could make a perfect square out of those 16 items, 4 by 4. If I were to give you 20 items, there's no way that you can make a perfect square using 20 items. You can make a rectangle, but you can't make a perfect square. So that's why those are called perfect squares. When you're factoring difference of squares, first you recognize that it's 2 terms, it's a difference, and both of the terms are perfect squares. So you're going to factor it to be the product of the sum and the difference of the square root of each term. And that's it. That factors to be x plus 7, x minus 7. And that's it. You can see if we were to multiply that back out, we'd get x squared minus 7x plus 7x minus 49. You see what the 7x's cancel out or reduce to 0, and that leaves you with x squared minus 49. So that's how you factor difference of squares. So try these next 3 on your own before you watch me go in and do them. This last one's a little tricky, but we'll look at it in a minute. So pause the video and see if you can do these on your own. And then let's look at number 8. Remember, you should first check for a greatest common factor. Every time, always, you should always check for a greatest common factor first. But there's no number that will go into both 4 and 81. But it is 2 terms, 1, 2. It is a difference of 2 terms, subtracted, and both of those terms are perfect squares. So it's going to be the product of the sum and the difference of the square root of each term. And that's it. 2x plus 9, 2x minus 9. Moving on to number 9. Again, remember to check for a greatest common factor first. In this case, I can factor out a 25. So that's going to give me 25 times x minus x squared minus 4. And then x squared minus 4 is the difference of 2 squares. That factors to be the product of the sum and the difference of the square roots of each term. So it's 25 times x plus 2, x minus 2. That means if I were to multiply all of this out, I would get 25x squared minus 100. And then lastly, any even power is a perfect square. So because this is a 4, these are both perfect squares. There's no common factor, so it's the product of the sum and the difference of the square roots of each one. And you might think you're done there, but you're not, because this is another difference of squares. There's no way to factor a sum of squares, so that stays just like it is. But then this one, I can now factor to be the product of the sum and the difference of the square roots of each. X plus 2, x minus 2. So that means if I were to multiply all of this out, I would get x to the fourth minus 16. And that is how you factor difference of squares. So in the next part 4 of the video, we'll look at factoring a quadratic in standard form when the leading coefficient is 1.